Cool, thanks for sticking around, guys. I know it's probably been a long day. So talking rabbits and AR use cases, just to add briefly to that introduction. So I'm the Chief Product Officer at Patch-Reality. We're a small team, so that basically means I do everything that doesn't involve writing code. Patch-Reality is a boutique XR consultancy, so we help big companies figure out how to fit XR into their processes and hopefully do so profitably. And we also develop custom solutions. So lately, we've been doing a lot of work with R&D departments over the last year and a half at big companies, building proof of concept applications. And about a year ago, we started working with the 60 SDK. Who here is familiar with the 60 SDK? Great. So most of that work is under NDA because it's proof of concept work. We can't show those projects or talk about them directly, so for the rest of this talk, I'll be using our own self-published application called Babble Rabbit to illustrate our findings with 6D and connect them to commercial use cases. So, awesome. So Babble Rabbit grew out of our entry into 6D's demo challenge. You can kind of lower the volume a little bit, or maybe I can. Awesome. 6D put out a call in 2018 to have people build things using their SDK in a couple of days. This video represents our submission into that challenge. It was built with Unity, and we're using Apple's speech module, as well as a plugin, a speech-to-text plugin from a company called CocoSoft. After being selected as a finalist, we decided to invest more time into the app. It went from being called WYSIWYG to Babble Rabbit. And we spent the next several months getting it ready to release it in the App Store. And since then, we've continued to update it on a regular basis. And it's really kind of our sandbox application where we test out new ideas, new features, et cetera, most of which usually end up becoming part of a proof of concept for one of our clients. So the rest of this talk will center around these components of Babble Rabbit, and for each of them I'll be talking about the solutions we tried and ended up implementing and connecting those to some commercial use cases outside of a virtual rabbit application. So let's start with new user experience. So I'm including within new user experience both the first-time user and the returning user setup experience, which is very important within the context of 6D, as we'll get to. This is an area of the application that we iterated on significantly, and the key points of friction that we were working on were the user permissions and the relocalization and meshing. So for user permissions, we had initially started out just doing the asking permissions for the permissions all up front and using standard OS permissions dialogues. We got some feedback that was overwhelming for users. We have quite a number of permissions that we need in this application, as you can see. And we also felt that it could be a barrier to repeat play. So what we did was come up with a guided experience that kind of gives us a little bit more control over the messaging and lets us guide the player through it and bring them back if they decide to skip something. If anyone here is a Unity developer and they'd like to include that style of permissions gathering in their own app, we outsource that component, or we open source that component rather. We built it ourselves. And you can go to patchreality.com and download it if you're interested. So next up was the relocalization and the meshing. And so just to clarify my terms quickly, relocalization is the process of matching point cloud data stored in the AR cloud to the user's live camera feed so that we can precisely locate the user's device in space. And meshing is the process of generating virtual surfaces from point cloud data. For this application and for any 6D application, we need to relocalize at the beginning of each session. And we also need a minimum amount of mesh before we can bring the rabbit into the world. Relocalization requires lateral movement, or rather, it works best with lateral movement of the device, whereas meshing works best with kind of free roaming movement. And so our challenge was to create an experience that guided the user through both types of movement and did so in a playful way, since we're making a virtual pet application. We didn't want it to feel technical. We went through a bunch of prototypes. We were looking at chasing a butterfly around. We were looking at splashing paint around the room. In the end, we settled on this kind of orb-catching game. And by controlling the movement of the orbs, we're able to lead the user to move their device in the different ways that we need them to move it. So let's take a closer look at real-time meshing and occlusion, which is sort of the big obvious benefit of 6D. So just a quick note on the visualization of the mesh. The built-in 6D meshing visualization, which you're not seeing here, we'll get to it later, is quite good, and it would be a great choice for lots of different applications. In the case of Babble Rabbit, again, we were aiming for a broad audience, and we wanted the new user experience to feel fun and friendly and kind of appropriate to the theme. So we're using these little green sprouts of clover as a kind of subtle feedback on where the meshing is happening. We didn't want people worrying too much about individual vertices on the mesh. When it works well, the occlusion that's afforded by 6D is amazing, and it really helps deliver the illusion of virtual objects integrated with the real world. It's very fast. All of this is happening in real time. I didn't pre-scan any of this space. We found that it works best with large, kind of formal shapes that have a varied texture. Where you tend to run into problems is with solid, featureless surfaces or transparent, reflective surfaces like glass or a very shiny floor. Although I was actually surprised that it worked as well as it does with these concrete shapes because, well, they really just have dirt as their as their feature, but it works quite well. Objects that have holes in them, like maybe a chair where you should be able to see through the back of the chair because there are slats or something, or areas with lots of shadow or kind of splotchy sunlight that's of high contrast, can be problematic and can confuse the meshing. Occlusion is generally useful, I think, in nearly all AR applications, but just to give a couple of specific examples, you can imagine an interior design application where you need to place virtual furniture alongside real furniture and want it to seem like it's fitting together. This is now the 6D mesh visualization, this kind of green covering. And you saw dog pop out. That was me saying dog and the system hearing it. And for anyone who wants to try out the application, that is a kind of Easter egg for turning on the 6D mesh visualization. It's the keyword dog. Other use cases might be a retail application where you're visualizing store displays within the context of, like an end cap within the context of existing shelving, or a training scenario where you're augmenting very large equipment and need to show smaller pieces of equipment integrating into it and occlude properly. So let's move on to avatars. We believe avatars are a very useful feature for lots of applications. And I'm really referring to not necessarily cute, furry creatures, but any kind of on-screen character that is mediating the communication between the user and the software. They are a more approachable way to deliver messages to the user, and we think they enhance the sense of agency as well. It's easier to contextualize constructions within a space. One of the commands this is showing one of the commands in Babble Rabbit, which is follow me. I think it's also a good example of the real-time meshing. This is sped up slightly, just so you don't, it's not as painful to watch, but basically the rabbit is constantly looking for a path to a point on the ground that's about a meter in front of the device. So we're raycasting against the 3D mesh in order to know where to tell the rabbit to go. So there's this kind of invisible targeting reticule you can imagine. And we think it's a good example of how a 3D mesh is much superior to a plane-based system for applications like this, because it allows us to more effectively translate screen position into an interaction in 3D space, so we can know more precisely what the player's focused on. This is a hide command, which I think is a good example of how an avatar can really draw a user into the space. Potential applications, new employee training, where it's kind of delivered by the CEO or a specific leader within the company. Orientation to an event, such as a conference or a wedding, so kind of a welcome app that leads people around the space and to key points in the space. Or a sporting event. You can imagine like the team mascot leading fans on an experience around that team. So speech recognition and voice UI. I think this has a little bit of, this has a little bit of audio, which I'll talk over it. Bang also works for Playdates if you want to try it out. So obviously this is not a pure voice UI like Alexa. So it's much simpler in many ways. We are using visual prompts and accepting voice as input. And our thinking was that by having users issue commands using their voice, it would enhance the sense of interacting with a creature in the real world. It feel more natural. Initially, we had toyed with the idea of having all interactions in the app driven by speech, but it just seemed kind of clumsy or artificial to have someone initiate a physical action, like you can play fetch with a little stuffed rabbit, or you can throw out a carrot, and doing those things with the voice seemed a little awkward. Now, there are definitely some challenges. Some of them are visualized in this video. Background noise can be a serious issue. Simple words are often misunderstood. So early on, one of them, instead of follow me, it was saying halloumi. Every single time we said follow me, it was producing the word halloumi, which is a fried cheese, some of you may recognize. And so that led us to develop a system of checks. So we're kind of listening for, because we have a more limited set of commands, we're listening for specific phrases, and we added a substitution list so that if what the system thinks it heard was halloumi, we just substitute for follow me. The side benefit is that you can use the word halloumi to get him to follow you, which is nice. And you can see during this video that the system is actually interpreting bigger as figure, and more interestingly, interpreting don't move as Donald, which I took to be a kind of subtle political statement on the part of the rabbit. So another way we're reducing content is we're modularizing the interpretation based on context. So playing with the rabbit is one mode, and another mode is rabbit naming, and another mode is naming a place within the wayfinding, which I'll get to later. So in those contexts, we kind of hear a phrase, we switch to a different UI, and then we're listening for the key word. So you would say like, you are, or your name is, and then we listen for the next word to be the name of the rabbit. And we show you what we think you said, and you can approve it. Potential applications, you can imagine any application where you need to annotate, so leaving contextual notes for coworkers, or navigating a multi-step maintenance process where it would just be clumsy to be clicking through with your hands. Basically anywhere you would want a hands-free navigation. So in Babble Rabbit, users who are on the same Wi-Fi network can view one another's rabbits in the same space. We call them Playdates. And here's some examples of how that works. We're using Unity Mirror, which is an open source plugin. As I mentioned, you just need to be on the same Wi-Fi network, so there's no account creation or lobby system like you would find with lots of multiplayer systems. It will probably surprise no one to hear that it has a huge impact on the user experience. It just creates this kind of immediate interaction between users, and the emotional impact is magnified many times over. We think it's a particularly good fit for AR applications because people are in the same room. And we found that even something as potentially dry as collaborating on the layout of furniture within the space suddenly takes on a kind of a game-like quality. Just a quick implementation note. So for multiplayer, we make the host user localized first. This way we are sure that there's some cloud data for subsequent players to localize against, and so that the coordinate systems are synced up. Potential applications, real-time interior design. We have conceived of kind of a highly interactive visual brainstorming, so like people moving around a space and using a library of objects to do like a mind mapping type of exercise. Communication amongst the team or tracking of one another's location within a large industrial space, a factory floor, etc. And that's a good segue into interior wayfinding. So this is the least ready for prime time feature within Babble Rabbit. It's the area we've been prototyping within. As I said, Babble Rabbit is kind of our sandbox application. So the end goal we have in mind with interior wayfinding is that an administrator could mesh a space, label points of interest, and then end users could ask for directions to any of those points of interest. So right now, this is in my local Lidl. So this is one of those modular, those contexts. So as soon as I said, this is the UI switched and it was listening for me for the next word, which it applied as the label. This is slightly sped up. I'm not running through Lidl. Tomatoes and wine. That's my focus in Lidl. So as you can see, that's putting a label into the world, and then when you're elsewhere in the space, you can tell the rabbit to go to and then label name. And he'll take you there, assuming he can find a path from his current location. And there's also these kind of yellow dots that trace the path to the next spot in the space. So this prototype is fun to play with. It is far from perfect right now. The pathfinding algorithm often gets hung up on holes and floaters that are quite common within the world mesh. We have some ideas about how to address this in future iterations that we're working on. So you can imagine using this in a retail setting, so malls, department stores, large office buildings where you need to send visitors to a particular company or to a specific meeting room, or in an industrial setting, so directing a user to a piece of equipment or potentially to the location of a fellow team member. So that's my talk. Babble Rabbit is in the App Store if you want to play around with it. Like I said, dog is the magic secret word to turn on the 3D mesh visualization, which I think this audience might find useful. I'm happy to take any questions, and my email's there if anyone would like to contact me. Thanks a lot.